Hey folks, how's it going? This is Mr. Moray, and I want to welcome you back to another great week of distance learning. We are already in week 10, and the end may just be in sight after all. So, in this one, what I'm going to do is we're going to be talking about compounding interest. Please make sure you've seen the compounding interest formula. This was done in a previous lesson. If you've seen it, or you could maybe pull that up, it would be really helpful for solving this problem. It is important we get some practice with it, and it's based on that. If you haven't done the compounding interest activity and or seen it in the hangout, I think we did maybe one example of it. I'd really recommend you check that out before doing this, because then it will make this a more meaningful activity for you, and I think it will be like a more valuable practice so that you can see if you actually understand. So here's the situation. At the age of 18, you open a checking account with $2,500 you've saved from working and graduation gifts. Okay? The account has a 3% annual interest rate that compounds monthly. Assuming you do not deposit any money into the account or withdraw any money from the account, how much will be worth in 50 years when you retire? Okay, so we're just simply dumping 2,500 in and we're leaving it. We're not touching it. We're just simply saving it up. Now, this is unrealistic, of course, because even if this was a retirement account, you would at least be contributing to it. So what we're going to actually get in this answer is actually the minimum amount you would have, right? You'd have at least this much. You're actually, if you think about it, if you continue to deposit 2,500 each year, or even like 500 each year, you're going to have a lot more than this. Okay. So, but in any case, here's what I want you to do. I want you to pause the video. I want you to use the compound interest formula to solve this problem. Then when you're ready, unpause and you can see what I got. All right. So hopefully, folks, you're able to do this. And hopefully you remembered when you get your final answer, because you're probably going to get a lot of decimal places, you do want to round to 2 decimal places because we are talking about money here. Okay, so what is our formula? So remember, the compound interest formula says that the current value amount of a particular account that's been compounding is given by the principal, in other words, the current, or what you started with, times 100% plus the rate, the annual rate, over the number of times per year that interest is added, compounded, times that number again, or rather to the power of that number again, times the number of years that the account has been open. Okay? Remembering that typically when a bank advertises an interest rate, they divide it by the number of times per year that interest is compounded to give you your interest rate per each time interest is added. And when I say added and compounded, those are more or less used interchangeably. Okay? Because then think about it. In a year, right, it'll be r divided by 12, but then there will be 12 times per year times 50 years. That, right? Because if you think about it, again, interest compounds 12 times per year. But if there are 50 years, right, then what that means is that interest is effectively added 600 times, right? And so to represent adding on interest 600 times, you need to multiply by that special 1 plus thing 600 times, and multiplying by that same number 600 times is the same thing as raising it to the power of 600. Now, how much did we start with? We started with $2,500, and then our interest rate is, remember, again, you always use a decimal, you never use a percent. If you plug in 3 means 300, right? Percents are not meant to be put into equations. They're meant to make numbers look nicer, right? The fact that you see that thing over thing means that it's supposed to represent 3 out of 100 per 100, or 0.03. It's not meant to just be plugged willy-nilly into an equation. Okay, it doesn't work like that. So out of 12 times per year, interest compounds times 12 to the power rather of 12 times 50. And this would be typed directly into your calculator. I would recommend considering maybe doing some kind of sprucing up with some things. I think it's probably in your best interest if the interest rate thing will simplify. So for example, I put it in, if you put it into your Desmos calculator, and by the way, this is Desmos' scientific calculator. See, and then if you can do the 1 plus, so 1 plus 0.03 over 12. So I have 0, 0, 2. And then if you can get the exponent, it helps too. It's not necessarily required depending on what you're using as your calculator, but it does make things a little bit nicer. Okay, again, not required. You should get the same answer either way, but nice. So 2,500 times 1.0025 to the power, and I'm going to do shift 6 or just hit this button. Now you can see, and actually because I'm on Desmos, I can save this. So I'm going to now show you what I would have gotten if I had just not been, tried to get cute with it and just done it like this. To the power of, and just be careful, if you want to do operations, you need to put the parentheses in there, 12 times 50. Okay, you get the same thing either way. See, you can see me alternating between. Okay, so the final answer is, assuming you put absolutely no money in at all, you're looking at least $11,183.27. Assuming you put no additional money in at all. Now, if you were to put, let's say, $500 in each year and you want to know what happens, well, what you can do actually, if you want to see this situation, go to the payoff calculator, set 2,500 as the original amount. I think this actually might work. Set the APR as 0.03. Okay. Set the compounds per year as 12 and the compounds per month as 1, and then set your monthly payment as a negative number, because then that will be like adding on each month. And it might, and I'm not sure if this is true, it might actually be able to show you how much it would be worth in the long run. So it actually might be able to go in reverse. No promises, but there are plenty of calculators online that will show you what you would get if you actually not only just left the money in there, but added it on. This is an important problem because if you think about it like this, I'm going to show you the impact right now of how much time makes a difference in money. And this is why by the end of this, you're going to see why people tell you that it's really smart to start saving for retirement at a young age. Now, imagine if I was 28. Imagine if I said, if I was 28 when I first realized, man, I should really have put money away. Now I only have 40 years instead of 50 years to save. I only have 40 years instead of 50 years to save. Look at the difference of taking away 10 years. Now the same amount of money will only be worth $3,000. It will only be worth $3,000 less. So that's $3,000 you're not going to get simply because you waited those 10 extra years. Think about what $3,000 is going to buy you in retirement when you have no income because you're not working. Okay, what about if you'd realized when you were 38? You would now be making almost half. So that's like saying, I'm going to cut your money in half. So think about what a difference that makes. Think about what your earnings potential is when you start saving at a young age. And so this is why people say starting saving for retirement at a young age, 18, is one of the smartest things you can do. Now you're going to say, Mr. Murray, why would I waste my time saving for retirement at such a young age? I'm not anywhere near retired. And the reason is because of exponential growth. Because the money you put in retirement is not just going to go up by the same number every year. it's going to go up by an amount proportional to the amount of time that you've had the money in the bank. And the only thing in your life that you can control is time. The more time you allow your money to grow, the more that it can be worth. But again, thanks for watching. I encourage you to like and subscribe so you can stay up to date with all the latest videos. But don't forget to love math, and remember, you can do it.